Good afternoon, my dear students. This is one more problem related to a center of pressure. In this problem, what is saying? There's a water tank of water, or a tank containing a water up to 0.5 meters. This is up to 0.5 meters water. Then some oil is there, a immiscible oil. That means it will not mix with pure water. That means it is looking like a precipitation on the water up to 1 meter height, whose specific gravity is given as 0.8, is filled up to 1 meter height. He is asking total pressure on the side of the tank. See, this is the side of the tank. On the side of the tank, either any side of the tank, how much pressure is acting is first question. Second question is position of that total pressure of one side of the tank, which is 2 meters wide. He is saying the water tank wide is 2 meters. So we'll see this problem detailed. So whatever the data given, same I wrote here. Specific gravity is 0.8, that's why multiplied with 1000, then 800 kg per meter cube. And density of water I know, 1000 kg per meter cube. And the width of the tank is 2 meters. So if you observe, this total tank I have divided into 3 portions. First 3 points, not portions. A, D, B. I wrote here B, D, A, C, A, D, B. So if you observe, what is the pressure acting at A? 0, because it is free to atmosphere. Okay, the pressure intensity at A is 0. And what is pressure intensity at D? Up to D, if you observe, only one type of fluid is here. That is your liquid. That is rho G H1. Rho is how much? 800. G is 9.81. And H1 is how much? 1 meter. Now, I want to calculate what is the pressure acting at B, because next step is B only. So if you observe, for that first I am writing pressure acting, this I am writing as P2. Sorry. Okay, P2. Let it is P1, it is P2. Coming to the P2, how can I write P2? So rho G H1 or rho 1 G1 H1 of liquid of 0.8 specific gravity plus, as well as water pressure also acting, rho G H of water. Now the P2, which is equals to this, already we have calculated rho G H1, which comes out to be 7848. See here, already calculated, plus now rho of water is 1000 into gravity is 9.81 into height is how much, which is 0.5 meters. So from this, if we calculate, this value is coming out to be, the calculator, 4905. If we add 4905 and 7843, this comes out to be 12753. From this, I can clearly make a note, or I will draw this diagram. Coming to this diagram, if you observe, it is drawn between your pressure and force. It is the area diagram. Okay, if you observe, what is pressure here? 0. On the horizontal axis, pressure is taken 0. What is the pressure at this junction? That is P1 pressure, 7848. That means when I compared here pressure 0 and coming to here it is 7848, the meaning is it is moving in a triangular fashion, because first order curve, if you observe all first order equations, there is no second order equation. If it is second order equation, then we can write it as a parabolic curve, but it is a straight line, first order curve. So I connected with a straight line, so it is forming a triangle. So if you observe, what is the pressure in the bottom portion, which is P2, what we considered just now, it comes out to be 12, 753, which is a combination of 7848 plus 4905. Okay, it's clear. The 4905, 4905 indicates the pressure due to water, and the 7848 indicates pressure due to liquid. That is clear. So with this diagram also clear for you. Now I want to write what is the force 1 acting on this triangle. Okay, how can I write force acting on the triangle, which is equals to area into width of the tank. Okay, area is how much? Area of triangle ADE. So if you write area of triangle ADE is how much? Triangle is half into base into height is area, half into, sorry, 1 second. Okay, half into base is how much? DE into half into base into height is AD. Clear? This is area of the triangle. F1 force is nothing but area of the triangle into width of the tank. What is the width of tank given to you? 2 meters in the question. So force 1, F1 is comes out to be, so what is the value of F1? Now substitute all variables, half into DE is how much? DE is 7848, which is pressure, into AD height is how much? 1 meter into 2. You calculate, 2 going to cancel. So it comes out to be 7848 newtons. So the value of F1 force is 7848 newtons. Similarly, F2 is equals to, what is the force 2? Force 2 is the area of, if you observe from the diagram, area of this rectangle into width. So area of rectangle into width. So what is area of rectangle? Area of this rectangle is 0.5 into 7848 into 2. So 0.5 is 1 by 2, 2 to cancel, then it also comes out to be 7848 newtons. Now calculate F3, which is equals to, how can I write F3? If you observe area of this triangle, so half into, what is base of the triangle? EF, sorry, FC. FC is 4905. So it is 4905 into height is 0.5. So if you solve, it comes out to be, that's it. Okay, sorry, unclose it. Yeah, 1 second, I'll repeat. Area of this triangle, half into base into height is 0.5 into width is 2. So if you solve this, so 2 going to cancel, then 4905 into 0.5 comes out to be 2452.5 newtons. Now I need total force, which is equals to F1 plus F2 plus F3, which is equals to total force acting on the system 18148.5. Okay, what is my intention to calculate? Total pressure force. And second question also I have, what is that second question? H star I have to calculate. How can I calculate H star? So earlier only one fluid is there, that's why I used a formula directly. But here 2 fluids are there. Only one method I have, that is derivation method. So F into H star. So simply I am writing the moment. So if you write moment, F into H star is equals to, so write moment. Now F1 into distance. F1 into, so simply force into distance, F1 into perpendicular distance. What is the perpendicular distance? If you take a triangle, right angle triangle, where the centroid will act for right angle triangle? H by 3 comma B by 3, that you learned already in the engineering mechanics. So this distance is H by 3. What is the remaining distance? 2H by 3 is the remaining distance. So now if you observe, this distance is how much? 2H by 3. So F1 into 2 into what is height? Is 1, 2H by 3 plus second force is F2. You observe F2 acting at a distance of, what is the height? You observe this. This is the triangle. This height is half BD. This height is half BD. That means 0.25 plus 1. So 1 plus 0.25 plus F3. If you observe the distance from here to the top end. So this is 2H by 3 and remaining distance is 1. So 2H by 3. So first I'll write F3 into bracket start 2H by 3. It means 2 by 3 into 0.5. 2 by 3 into 0.5 plus, and what is the distance, remaining distance? 1. But the benefit, I'll repeat again. Simply I'm writing the moments, calculate center of pressure, that is F into H star, moment F, total force of this particular system, let acting somewhere here or somewhere here. The distance from this point to free surface is H star. So that F into H star is equals to F1 force So F1 force into distance is 2H by 3 plus F2 force into this distance is 1, 1 plus, and this is half distance. So the distance from here to here is F2. So 1 plus 0.25 plus F3 into 2 by 3 into 0.5 plus 1. This is clear. Now I know total force, that value is 18148.5, which is equals to, what is F1? I know this also, 7848 into 2 by 3, okay, plus what is F2? F2 also 7848 into 1 plus 0.25, you can reduce this equation because of space constraint. So this comes out to be 1.25, just add it, plus F3 how much? I know that already 2452 into, you calculate this total, 2 by 3 into 0.5 plus 1. If you multiply this total equation in the calculator, only H star is remaining. That H star you will get, which comes out to be 1.009 meters. I'll repeat again this part. First I wrote a moment equation. If you understood that moment equation, remaining part is substitution only. From that I can calculate. That means it is very clearly saying the total pressure of the body, the total center of the pressure is acting at a distance of 1.009, which comes out to be 1 meter distance from the free surfaces it is acting the total pressure. So if any doubt, we'll discuss this problem in the common hour. Okay, thank you. Only.